Well, we got a 2022 Hyundai Palisade here, and the customer concern is it's a no crank. You push the button and it doesn't crank. I can't hear anything happening out under the hood. No starter click, no nothing. So I've got a pre-scan here and it is all green. There's no codes at all in this thing. So first things first, you've got to know what's controlling the starter. Okay, so on the wiring diagram that I've got pulled up, y'all see a screenshot here of it. The start button goes to a module called, they call it a IBU. I have no idea what that stands for. I'm sure somebody will leave it down in the comments for us. But it sends a start command basically to the ECM, and then the ECM controls the starter relay. It controls high side and low side of the relay, and then of course the relay just sends power through it to the starter solenoid. So by not hearing any clicks at all, I really want to just check a few things. First, we're going to look at some live data. So let's go into the ECM here. I'm going to look to see if we've got some like starter commands or starter data PIDs basically, to see if the ECM's trying to start the engine or if it's seeing a start request basically. So give this just a second here to load up some data PIDs for us to pick. We're just going to use this search function, and I've already kind of looked at this a little bit. So we've got two key data PIDs here: start request from key and starter relay on signal. So let's look at that, and we're going to graph this so it's kind of easier for y'all to see. And we're going to just push the brake down and we're going to hit the button, and as you can see, both go to on. If I let off the brake, it should turn these off in just a second. So the ECM sees the start request, so we can rule out anything with the key, the whatever this IBU is, and really we can kind of ignore the ECM. We need to kind of focus our attention on this start relay and do some testing there to see if it's actually getting a start relay on basically from the ECM. To help us out with that, we're going to be using this RelaySim Pro from AutoDiagnostics.com. Recently I had a Dodge Journey that had an interesting issue where the starter relay, just like this one, was controlled high side and low side. And that day my brain was just really not working too great. I spent way too long on this thing trying to figure out in my head what the relay circuits were and things like that, and I just was a little frustrated with it, and I was like, there's got to be an easier way to test that. So I did some research, and then AutoDiagnostics actually just literally the next day sent me an email seeing if I want to try this thing out, and I was like, man, I really could have used that today or yesterday. So they have sent it to me, and here it is. It's the little controller tester and then you get a lot of these little relay harnesses with all the different little relay connector ends like that. Before I forget, I'll leave a link to this down in the description, but you can go to AutoDiagnostics.com and find it there. This does ship from, oh man, I can't remember now. It does come out of Europe. So it took me a week or so for it to actually come in, but they make a few other great tools. So links down in the description if you might be interested in this. The fuse box lid here says our starter relay is right there, so we got connector, so that should be the starter relay right here. So let's go ahead and we're going to pull that thing out. And I've not even had a chance to use this thing yet, so we're going to figure out if this is going to help me or not. First off, that relay looks fine. I don't see anything wrong with that relay. The connectors down there, all that looks fine. So let's find the connector that's going to fit that, and it looks like it should be this one here. All right, so let's stick this thing down in here. I feel like they've got a special little notch in this thing or something. It's a little, it may be slightly wider or something. So it actually does fit. It's just really tight. Even this was actually kind of tight for me to press. Off camera press this all the way back down in there and then try to pull it back out, and this was really tight. So it's just, they make this extremely tight, so no fault to them at all. There is a little ground wire that you need to connect, and once you do, it'll turn on by itself, and you can see that we've got 12.2 volts, and this is going to be coming in. If I can get some shade for y'all, this is going to be coming in on the pin 30 from here. I think it's 30. We could look at this little book here and see. This is literally the first time I've used it, so I need to know a little bit about it. VA meter, so yeah, 30. So coming in on 30 is sampling it right here, and it's got a current shunt in here for this to also read the current. It's basically reading voltage and what the voltage is after the shunt, and yeah, so that's one thing that I wanted this one for, was for this current reading right here. And we can change this dial, and it's going to tell us kind of what each thing has on it. So 87A, that's going to have 12 volts because 30 and 87 is a normally closed contact, so 87 is 0. That should be like that because this is open. 86, we've got 9.8 volts. 85, 11. So these are our two coil wires. So 85 looks like that would be our high side power coming in, and 86, since it's slightly lower voltage, would be the voltage drop through the coil, and this should be our low side command. So when we hit the start button, this should drop to 0. So let me see if I can set this up to where I can see it and y'all can see it, and I can push the start button. I know that's going to be pretty bright, but you can still see that it says 9.7. So let's hit the start button. and that does go to 0. So we do have power coming in and the low side control. So we could see that this actually dropped to 0. That's our low side control. Let's flip it over to 85. Let's do this test again. I want to make sure this 11.7 volts stays there. Make sure we're not dropping voltage as the ECM tries to turn everything on. I don't suspect that we are. And yeah, y'all can see that. So I'm pushing the button now. We had just a tiny bit of voltage drop, but yeah. So that quickly determined that the ECM is doing its job. It's doing high side and low side. Now this thing also, inside of it, has a relay. So if the problem was this relay, we would have just had the engine crank over, because this supplies a relay inside of it. That's what was on this diagram. Let me go back to it. You see we've got our 87A here, and then 87, our output. So the way this is kind of looking, I'm not sure if this is also connected up here or not. Maybe I'm wrong. Maybe this won't actually turn a contactor on, but we can do it here with the little activation dial. And you can see I've switched this over to 87. We've got 0 volts. And let's switch this to off and on. 31 amps. So I can actually hear the starter down there trying to do something interesting. Let's go back over here to this other dial. Make sure I'm seeing this right. So turn this on, 30 amps. I'm gonna put y'all down here with the microphone so y'all can kind of hear this as it's turning on. So since I can hear the starter trying to do something by forcing it on with this tool and seeing the current, that 30 amps, I know I don't want to leave that dial on very long, because that's going to burn some stuff up. And it's kind of actually looking like we've got just a bad starter on this thing. Maybe. We do need to verify the engine will actually rotate with a ratchet, you know, roll the engine over by hand. And really we need to do some further checks here on the engine to make sure we've got good ground getting to the engine block. Because we don't have a good ground, the motor is not going to have a path of current back to the battery. But still, this is a quick, easy little tool to test relays and stuff. I want to see if that does anything, that current, when I try to just leave it like this in this mode where this is off and this can operate. It's kind of a little confusing. I'm not sure if this has a relay built into it or not. Maybe DITEX can comment down here and let me know for sure. I feel like this should have a relay built into it so that you could see the current flow through it under normal operation. which, I mean, it's still the same as turning this dial. So, and there is these fault lights. Red, I'm pretty sure, is like an open circuit or something. I'm not really sure. It's all in here, what the lights mean and stuff like that. I'm not going to get too into that. But let's continue on with our diagnosis. We at least now know we need to focus on the starter and engine mechanical side of this thing. We've proven electrically coming in and out of this relay box. So, and we've even proved that the starter solenoid, the solenoid that's on the starter, is flowing current. It's flowing 30 amps. We've proven that. So the ground to the engine block and back is at least capable of carrying 30 amps. So let's try and spin this over by hand, and we'll do just a ground voltage drop test real fast to verify that we do have a good engine ground, and we'll go from there. All right, I got my handy dandy spline ratchet wrench. This is a 22 millimeter. I'm pretty sure that's what this bolt is on here. So we'll get that on there and see if we can rotate this by hand. I do have the keys off. Make sure you do this with the key off. Some rare engines, ECUs, they don't necessarily care about a starter input. All they need to see is crankshaft rotation to start firing coils and ignitions and things like that. So do this with the key off, trust me. But anyways, let's see if we can rotate this by hand. Yeah, and that's not even that bad. That's pretty easy. So that rules out a mechanical issue, like a locked up engine. I mean, we do know these things like to do stuff like that. So yeah, this thing definitely is not locked up at all. Also, always rotate clockwise. I don't know of any engines except maybe, I think there's some marine engines out there that rotate counterclockwise. So rotate clockwise. If you rotate counterclockwise, you are moving the chain slack, the timing chain slack, to the wrong side. There is no tensioner on that side to take up the slack. And then you can do things like jump teeth. So don't do that. Always clockwise. Like if you're standing at the front of the engine, clockwise, like a clock. That's how they rotate. Don't go backwards. That's bad. So, but still, mechanically, we're fine. Now let's just do a quick voltage drop test from the battery negative to the engine block, and just check for voltage drop. So we still got this hooked up because we're gonna manually switch this to 87 to send power to the starter to try to run the starter. And I want to see, because you got to do this loaded, you got to do a loaded test where you got to put these grounds under a load like the starter. So I've got my negative lead here is just connected to the battery negative post. My positive lead, I've just got an alligator clipped to a bolt that is attached to the engine. And as you can see right now, we've got no voltage drop. Let's move this over here so we can turn this on at the same time. What I want to see is when this turns on, how much voltage do we read right here? If this stays under like 200 milliamps, you know, we should be fine. So let's turn this on. Oh yeah, 34, 35 milliamps. So these grounds are perfect. No issue with the grounds. There's one other cable we should actually be voltage drop testing as well, and that is the main battery cable down to the starter. I don't actually know where the starter is on this thing. It sounds like it's kind of on the back of this thing, and I don't have a jack with me to get to it or not, so we're basically going to call a starter right now, but I'm not going to tell them to put a starter on it. I'm going to tell them to plan on putting a starter on it. They're going to have to put it on the rack, inspect the cable at the starter, make sure it's not like broke off or anything like that, and do this voltage drop test from the battery to the starter and things like that. I won't be able to film that because it'll be in their shop and they'll probably be doing it and not me, or if I do come back and do it, it'll be just like a real fast kind of thing. So as of right now, it really looks like a bad starter. But like I'm saying, there's one other test that needs to be done. The power cable to the starter needs to be verified. So that's it. I've had this tool sitting in my van, I think, for about 2 weeks now, and I've been waiting for a good chance to use it. And this is a perfect scenario. We've proven we didn't have any power issue here. We've proven the issue is definitely at least between the power cable and the starter, or the starter itself. This thing right here did make this super fast to just rule out anything with that. There is a couple things I wish about this thing. Mainly there's one thing I wish this would have had that it doesn't have. And really it's not that big of a deal, because they send this little universal cable here. If they don't have a pre-made plug, they have this one where you can pin in your own leads. I do wish these were male ends, because if these were male ends, I could use my kit here, my terminal kit here. I could just pin these into these, and I could pin those into the relay box over there. So one day I will probably be changing all these over to male ends. But getting back to this, the one thing I wish they had have put on this thing, see how they have the ground here? You have this ground, it has to be connected, because they want a ground to this thing. They don't want to rely on any kind of ground through a relay. I wish they also had a second one here for power, because I don't know if y'all have run into any relays yet or not. I think Chrysler is a good example, where they have 2 starter relays. So they have one relay in line with another relay, so if relay 1 doesn't close, relay 2, even though it closes, still has no power to push on out. So I really wish they would have had a 12 volt in for each situations like that, where maybe you've got 2 different relays and they're in series with each other, because the way this has to get power to turn on from the pin 30, in a series situation, this thing wouldn't turn on if relay 1 never turns on. And that would be nice to have just one more little input, but like I say, you could use this and just bypass that with connecting this. I'm sure this is 30. Yep, that's 30. So you could connect that straight to your battery through a fuse or whatever, and then connect the rest of the pins like normal. And that would basically do what I would like, but it would be nice to just had one extra little plug here for a voltage input to it. They could have even like put a little fuse in line here or something like that. That would have been really cool. So maybe version 2 one day in the future, get an upgrade like that. But I do like it though. I really like the current reading thing. That's really helpful to see that, You know, I knew there was no ground issue because this thing will flow 30 amps. So I really wasn't expecting to see a voltage drop on the ground. So, but that's it for this one. Quick, easy. Sometimes tools make a big difference. You know, it's like a scan tool. Like, how many cars are you really going to be able to diagnose with a scan tool nowadays? Not very many. Relay testing. With the way they control these relays nowadays, you could do this with a test light, and that's what my method has always been, is test lights and things like that. This makes it a little faster. So that's it for this. Thanks for watching, everybody, and we'll see you guys later.